Good morning, guys. So we're going to be doing, based on this equation, we're going to find the mass of iodine that can be produced, and then in this situation, the mass of iodine that can be produced and the percentage yield of the iodine produced. So here I just rewrote this equation just to make it more clear. And so A is asking 88 grams of iodine for oxide. I2O5 reacts with 28.0 grams of carbon monoxide, CO. Determine the mass of iodine, I2, which could be produced. So before we can do this, we need to determine our limiting reactant. Because to find how much product our reactants are going to make, we have to use a limiting reactant because there's less of that. And we're going to use all of that amount. So let's find our limiting reactant by first converting what we have, which is 88 grams of this and then 28 grams of this, into moles, so we can compare it with the ratio. So let's see. 88 grams is, so 88, we're gonna, oh hold on, this is 80. So 80 grams of I2O5, 1 mole of this is this, which is our molar mass in grams, and you're gonna get this. So this is 0.24 moles. Okay, so we're gonna do the same thing for this one, 28.0 grams of CO. We're gonna get, so you put grams on the bottom so that it can cancel out. So we'll be left with the number of moles. Okay, so now that we have this, we can compare the ratio. So you have 0.99 moles of carbon monoxide and 0.24 moles of I2O5. So these are our reactants. These are these numbers, right? So let's look at our ratio. Okay, well let's first find how much CO is needed to react with 1 mole of I2O5, which is, when I divide it, I get this, which means 1 mole of this requires this much of this. Okay, so let's look at our ratio, which is 5 to 1. 5 to 1. So you have 1 here, you have 1 here. But this does not, this is less than this, which means that this is the limiting reactant. So we know now that carbon monoxide is our limiting reactant. Limiting reactant, which means this is excess reactant, because there's only 2 reactants in this equation. Okay, determine the mass of I2 which can be produced. So from this equation, this chemical equation given, 5 moles of CO produces how much I2? 1 mole, right? So it produces 1 mole of I2. Now, what do they give us? They give us this much. So we need to find how much I2.
So X mole of I2. So when you do that, X equals 0.198 moles of I2. Okay, so that is the number in moles. What they want is the mass, which when they say mass, they are always referring to moles. Mass, they're always referring to grams unless it states that they want it in moles. So let's convert 0.198 moles of I2 into grams. Write it on the bottom so it can cancel out. And how many grams? So that much grams in 1 mole of I2. And what you get is 50.25 grams. So that's how much can be produced. So what that means is 50.25 grams of I2 can be produced from 0.99 moles of carbon monoxide. Okay. If in the above situation only 0.160 moles of iodine, I2, was produced, part 1, what mass of iodine was produced? So to find this, what we know is 0.160 moles of I2. We're gonna convert it to grams. Okay, so where I got 0.160 is from I got it from here. So that's the mass of iodine produced, because it's already in grams, and mass is always referring to grams. So 40.61 grams of iodine. Okay. Now, part 2, what percentage yield of iodine was produced? So what we found earlier is this. So what this is actually our theoretical yield. So our theoretical yield is that 50.25 grams of I2 will be produced. But when we did this experiment, we didn't get that number. Instead, we got 40.61. So now we need to calculate the percentage yield. So, like I said, this is theoretical yield. This is what should happen. But during the experimental process, energy is lost, so it's basically never 100% or what we write on paper. So this is our theoretical yield. Theoretical means 100%. So what is the percent of this? So what's the percent? So when we do this, what I'm doing is I'm multiplying this by 100%, or just 100, and then I'm dividing it by 50.25, and then what you get is 80.82%. So this is your percentage yield, and that's it.